Hi guys, we are back for part 3 of lesson 3.1. Remember, we have learned how to solve systems of two equations in two variables with graphing and substitution. Today we are going to focus on elimination, okay? And that is our third method, okay? Before we get started on that, think back to substitution that we did yesterday, and it says when using substitution, how do you decide which variable to isolate and which equation to solve? Explain. And we are just picking up where we left off, so we are on page 34 in your Springboard book, okay? So thinking back to yesterday, remember I said it doesn't really matter which variable you pick to isolate, but we like to just pick what's easier, okay? So your easiest option, right? Don't make it harder than it needs to be. And usually that is going to be the variable with a coefficient of 1. Or even 1 or -1 would probably be your easiest thing. So if there's like a 1x or x by itself, that's what you're going to want to choose, or a y by itself, because those are easiest. You don't have to do any division or anything. You just might have to add or subtract something over, okay? All right, cool. So as it says here, another algebraic method for solving systems of linear equations is the elimination method. And if you look at your math term, it says in the elimination method, you eliminate one variable. So what you'll have to do is multiply each equation by a number so that the terms for one variable combine to 0 when the equations are added. So it's kind of like we're finding that additive inverse that we talked about in the beginning of this unit. Then you'll use substitution with that value of the variable to find the value of the other variable. The ordered pair is the solution of the system. Just like last time, we'll write it as an ordered pair. The elimination method is also called addition elimination method or linear combination method for solving a system of linear equations. But we will really just refer to it as elimination. Okay, so let's first look at this example that they have in the book for you on page 34, example B. And it says a stack of 20 coins contains only nickels and quarters and has a total value of $4. How many of each coin are in the stack? Okay, so this one is another word problem example to show you first. And it says let n equal the number of nickels and q equal the number of quarters. And you could do this with x and y also. They just chose the first letter of the word. Okay. It says write one equation to represent the number of coins in the stack and write another equation to represent the total value. Okay, well, they told us that there are nickels and quarters and 20 coins. So the first equation is however many nickels plus however many quarters, so n plus q equals the 20 coins. Okay, so the number of coins is 20. Then the second equation, it says it has a total value of $4. And we know what nickels and quarters represent. And so your Springboard book chose to use whole numbers. You could have also written this as we know that nickels are 5 cents, so 0.05 n, plus quarters are 25 cents, equals the $4 total. So you could have written it like this, but I think your Springboard book here is writing it basically just multiplied all of those so that it was whole numbers to make it a little bit easier for you. Okay, so that's where this came from. Basically just multiply everything by 100 and you'll have 5n plus 25q equals 400. And that's thinking of it as cents. So a nickel's worth 5 cents, a quarter's worth 25 cents, and $4 would be 400 cents. Okay. All right, so that's where the equations come from. And now let's get into the elimination. Okay. So it says to solve this system of equations, first eliminate the n variable. Okay, so to eliminate, what you're going to do is if we want to eliminate this n variable, right? We're looking at these here. We have n and 5n. And in order to eliminate them, they need to cancel out. So what cancels with 5n? Negative 5n. So that's why they chose to multiply the first equation by negative 5 so that those n values would cancel. Okay? Here's the biggest thing. Whatever you choose to multiply the equation by, you need to multiply to every term. So that's what they did here. It's basically like you're distributing it, okay? So they multiplied the n by negative 5, the q by negative 5, and the 20 by negative 5, okay? And then that's when they get this to eliminate, and they add everything else. So negative 5q plus 25 gives you the 20q, and negative 100 plus 400 gives you the 300, and then you solve for q to get q equals 15. So now we know, okay, there were 15 quarters in that stack, okay, in that stack of 20 coins. So then if we know 15 of them were quarters, let's plug that back into the original equation, which is what they did here. So 15 quarters plus however many nickels, you're going to solve and subtract that 15 over to get n equals 5. So now we know, okay, in that stack of 20 coins, 5 of them were nickels and 15 of them were quarters. So we would write that as 5, 15. Okay, and again, you can check your work by plugging back into the other equation, and that's what they did here. And they got 400 equals 400, so check, that works out. Okay, so like I said, your solution is there are 5 nickels and 15 quarters in the stack of coins. Voila. Okay, so that's an example of elimination. Let's try another one on the next page. So flip to page 35. And we are going to work on together. Let's do B. Okay. All right. So we have the system 5x plus 6y equals negative 14. And we have x minus 2y equals 10. And again, we're using elimination. Okay. And we want to either eliminate the x values or the y values. Okay. And we could do this either way, but if we wanted to eliminate the x values, what we would have to do is multiply the second equation by negative 5, because that would get rid of the x values, because 5x plus negative 5x would cancel. Okay. If we wanted to, let's say instead, get rid of the y values, we already have a positive 6y and a negative 2y. So in order to get rid of the y's, I could multiply the whole second equation by 3. And I'm actually going to choose to do that. Okay, so I'm multiplying this whole equation by 3. Okay, so that would leave me with 3x, because 3 times x is 3x. 3 times negative 2y is going to give me negative 6y. And 3 times 10 is going to give me 30. Again, please, please, please make sure you remember to multiply that 3 to every single term in the equation. Okay, I'm going to bring down my other equation, my first one. And now I am going to add them together. Okay, so what happens here is 5x plus 3x is 8x. My 6y plus my negative 6y are going to cancel, which is what we want. We want them to be eliminated, okay? And then negative 14 plus 30 is going to equal 16, okay? To get x by itself, I'm going to divide by 8 on both sides. And so now I know x is equal to 2. Okay. All right, now I'm going to take that 2 and substitute it back into either one of the equations. Doesn't matter which one, so I'm just going to plug it into the first one. So remember the first equation was 5x plus 6y equals negative 14. And again, like I said, I'm going to plug in that 2 for the x. So 5 times 2 plus 6y equals negative 14. 5 times 2 is 10, plus 6y equals negative 14. I'm going to subtract the 10 over. And be left with 6y is equal to negative 24. And then divide by 6 on both sides to get y equals negative 4. Alrighty, so I know that my ordered pair would look like xy, so 2 comma negative 4. But let's go back and just check our work really quickly. So I'm going to plug that 2 negative 4 into the second equation. So 2 goes in for x, and negative 4 goes in for y. And 2 times negative 4 is negative 8. And just remember that minus a negative is really like adding. So 10 does equal 10. So we know we're good. So your answer is 2 comma negative 4. Okay. So again, just think back to this step here. Remember, we were just looking at how we could eliminate a variable, and we chose to eliminate y by multiplying the second equation by 3. Remember that we also could have chosen to eliminate x by multiplying the second equation by negative 5. Either way, you would have gotten the same answer, which was 2 negative 4. Okay. Alrighty, so we will do some more practice with elimination in our Zoom. Please let me know if you have any questions. Have a good one. Bye-bye.